Angela, thank you. Good afternoon, ladies and gentlemen. It's a great privilege to have this opportunity to share some of the latest development of global autonomous driving technology with you. This presentation does not attempt to address every detail of new technologies, nor can I provide all aspects of the old AV development. This presentation intends to provide you an overview. There are various sources of information that are going to be cited in this material. When we talk about mobility, it's not just about car. There are many forms of transportations that can move people from point A and point B, as well as moving the goods. However, how to make that moving safely, efficiently, and comfortably, ultimately, we may need to resort to the autonomous driving technologies. SAE has constantly updated the definition of the autonomous driving, and recently China also published their definition, although actually quite similar to SAE's, but in more details of the definitions. Ultimately, when we talk about the responsibility of the drivers, up to level 3, the driver is still required to take charge upon urgencies. Only the level is raised to L4 and plus, the vehicle will take charge. However, the step up between L3 and L4 is actually going to be very big. According to McKinsey studies, actually the L2 and L2 plus features of functionality going to be the foundation of the further growth in next 10 years. And as you can tell from the chart, more than 50% of the future AV technology up to 2030 is going to be L2 and L2 plus technologies. And you can tell the complexity of the ADAS functionalities is increasing significantly. I really wonder anyone can remember every details of every items. So the question right now is, should we proceed with this way, laying bricks layer after layer, or should we go back to the drawing board to revisit and rethink how we approach the whole driving safety technology development? Actually, this is going to present different concepts and different challenges. And we know that some of the automakers and some of the pioneers are already doing that, and we will see how that going to happen in next few years. Fundamentally, we have 4 building blocks when we talk about autonomous driving. It's sensing, detection, perception, and decisions. Each element presents a different kind of technology challenges. For example, in the sensing categories, as we all know that camera, millimeter wave radars, and LiDARs are the primary source of the sensing at this moment. But it does not say that, for example, lower cost solution like ultrasound or infrared have no role playing in the futures. And who knows, maybe in the future there will be different kind of a sensing technology or even better sensing technology going to happen. In the detections, we can tell that 3D high definition mappings increasingly play an important roles. In terms of perceptions, localization, and C-V2X technologies are now expected to provide real-time information in order to support the perception development. And ultimately, decision-making is the key. How to utilize the artificial intelligence algorithm to make sure the decision is a sound and is the most robust way, and still have huge challenges. So through those processes, through those 4 building blocks, the information be reviewed, be analyzed, and be determined what to do next. And that information will fit into the vehicle and to command the vehicle maneuver. And we talk about the futures, we must talk about the new electronic architecture, so-called the EEA. Because EEA is such a fundamental change from the old way of design the vehicle using the distributed structures, which give you a cleaner and simpler way to structure your information sharing, flowing, and also computing. And as you can tell, now we are moving into the domain EEA. And some of the automakers are already looking at the zonal EEA. Those are the enabler to integrate bigger and faster computing capability into the vehicles. As the sensing and detection provide more and more large volume data into the vehicles through systems, those computing technology need to be integrated at every step in order to proceed a good determinations and decision making in the end. And we are talking about a software-driven futures. It's not just the safety-driven. It's about how to provide a lot of functionality, how to provide a new service to the user or riders in the vehicles, so we can create a different kind of AV ecosystems. Especially when we look at all the functionality required, it's not just inside the vehicle, it's between the vehicle and the cloud as well. So having said that, how to make that efficient is basically we need a very robust electronic architectures, and we need a lot of computing power both in the vehicles and also in the cloud. Consumer does value those new technologies. According to the recent study of the McKinsey, although it's based on China consumers, we can tell that people do understand the importance of the ADAS connectivity and autonomous driving, and do value those new technology which to ensure their driving safeties in the futures. And actually in other major market, we see the similar trends, which means that all those technology will have an easier way to be integrated into the future platform and also vehicle development. With that, and also with the new world of technology development, the expectation is that after 2030, the private AV, shared AV, and also mobility as service going to have exponential growth, which is driving the new era of the autonomous driving, and also can provide even bigger value to all the customers. However, when we address the capability of the vehicle, we also need to look at what can be done outside the vehicle, because no vehicle can be powerful enough to handle everything, at least not in the foreseeable futures. In order to do that, we need to think about how to connect the vehicle to the infrastructures. As we know that intelligent transportation system, so-called ITS, as part of the key element of the smart city, is one of the key to support the vehicles in different ways. It's to help the vehicles to provide their information which the vehicle itself may not be able to see or may not be able to sense. For example, information about blind spots, which sensing or other information cannot penetrate. Therefore, those connections is critical for a full autonomous driving capabilities. And we're talking about the connection, we're talking about connectivities. We can tell that edge computing can support the connected and autonomous vehicles by offering the network and to share the data analytical burdens dynamically. So different kind of workload can be handled in different kind of way, which is also a very efficient way in terms of computing power allocation and the cost effectiveness. And to some extent, the vehicle itself also can be treated as edge. So the vehicle can concentrate on handling all the necessary functionality inside the vehicle, especially on the safety elements. And other elements, for example, navigations and other telematics or infotainment related informations can be connected into the network and use the computing powers in the cloud to help them to generate informations to enable other service inside a vehicles. Here, just some of the information we can show you about the ITS project being conducted globally. Of course, they are more than just this one, and there are more to come. We are talking about the autonomous driving scenarios, and there are many kind of scenarios which we can talk about. Here, we're just going to give you some example in next several slides. The first one is the private AV, which you can tell that it's trying to be an extension of your private life. It's an extension of your home, extension of your office. So you feel comfortable, secure, and safe when riding your own AVs. The other part is the shared AV. Shared AV is part of the big transportation systems. The goal is to provide efficiency and convenience to the passengers who ride on those shared AV with sufficient security and comfort. On the commercial front, depends on the needs. There are different kind of way to move the goods around. Basically, there are three ways of commercial transportation. The first one is long haul. Basically, is like across continent from New York to Los Angeles. How to make that in a more safety way and a more efficient way, especially on the highway. Just like an airplane, once the airplane takes off, you can tell a lot of time the pilot switch on the autopilot, and you can do that on the highway as well, especially when you have an efficient way to do the platoons and the navigations. The difficulty is when the vehicle get out of the highway and get into the urban areas, because the variables, a significant increase in different kind of magnitude. How to manage the urban transportation, which require significant infrastructure support as well. Because there's so many things, not just the map, not just the AV capability itself, there's so many road condition change, traffic condition change, which need to be managed through the big network and fit into the vehicles. And between the vehicle and the infrastructure service center, then decide, for example, what kind of route need to be changed or which route is the most efficient way to ship the goods or passenger from one point to another one. And then we have the last miles delivery. And as we can tell, recent years, more and more the startup or the newcomers focusing on the last mile deliveries. This, for example, from the terminal of the subway to the industrial park, or from the supermarket to your home. However, if we look at the most feasible way to utilize different kind of AV technologies, probably the way to operate within the control environment could provide a breakthrough to realize some of the autonomous driving business. For example, in the mining areas, in farming, in harbors, warehousing, industrial park, even on the street cleaning, as long as those routes are regular, are repeated, and also less variables. For example, some of the street cleaning vehicles can operate during the midnight when the traffic or the pedestrians are much less and safer to operate those autonomous vehicles, then we can do this kind of business. So those are the areas we should put more information, more resources in and see how that can be developed into a viable business. And we have all those cute little food or grocery deliveries, and you probably already seen some of the video clips to show those vehicles being operated. Basically, those are to support the business and the customer within the short distance deliveries. Then we talk about what happened right now. We're not going to dive into every detail of technology. In the next few slides, I'm going to give you some example about the pilot programs. The first slide give you Waymo, Cruise, Argo. Those are very famous in terms of the pioneering some of the AV technology, especially in the computing way, or artificial intelligence way. Waymo and Cruise recently obtained the permit from California government for the commercial AV service, which is a significant step, actually. We will see how that goes from now and how they penetrate eventually to set up a viable business structures. Argo similarly are working with Ford and Walmart and other partners to develop the AV commercial delivery business. Mobileye, as we know, is one of the pioneers utilizing computer visions. Now they are expanding by integrating other technology into their AV technologies. They are also conducting the robot taxi environment test in New York this year and plan to expand the service to Europe next year. Zook, acquired by Amazon last year, rolled out a beautiful L4 Plus robot taxis. It's quite impressive. I would suggest you to take a look and to understand, because it's well designed and well thought through vehicles. However, whether that can be realized in the future as a viable business or the way integrate into the ITS remain to be seen. And then we have Tesla. Tesla is continuing pushing the boundary of its FSD. And we all know that at this moment, FSD cannot be, say, qualified for L4 or F4 plus. But information telling us that there may be some change coming in next few months. We are eager to see what Elon will unveil by end of this year to see the new direction of the FSD. In China, similarly, we have many AV startups. In next two pages, I'm going to give you some examples. The first one is AutoX. They are now piloting or testing their robot taxis in Shenzhen City, that's south of China. Baidu, using their Apollo platform, and also are doing robot taxi pilot in several cities in China. Similarly, WeRide also doing that. But WeRide also venturing into the commercial AV. Recently, they announced a collaboration with General Motors for the commercial AV development. Back to the Apollo. Apollo platform originally was designed to be an open source platform with all the partners joining in. But recently, Baidu also announced cooperation with GD Motor to develop specific vehicles. And then we have another very capable newcomers in Pony AI. Pony AI, similarly, with the support of some of the automakers, are starting their robot testing in California and also in Shanghai. Then we have Huawei. Because the difficulty in their smartphone and also the network business, Huawei is pivoting to the automobile business. The whole picture is still not clear to us. As far as we understand now, they are trying to develop the full vehicle system solutions. And they are working with several China's local brands to develop the vehicles. Whether Huawei going to be an automaker in the future is another subject everybody is interested in. Talking about the commercial vehicle, especially the semi-truck and also heavy truck, we must talk about TuSimple and Araro. Those two are very capable AI AV development pioneers. Of course, their technology are not just limited into the trucks. They are also put their technology into different kind of products for testings. For TuSimple, they plan to demo their self-driving truck this year in Arizona, later part of this year. And we all know the Araro is working with Volvo Trucks. Volvo Trucks just announced to integrate Araro's technology in their highway autonomous driving truck. Araro also plans to provide the full driverless delivery by 2023 to FedEx. So a lot happening right now. A lot of things are happening right now, and we are eager to see the progress in these areas. Then back to the cute little delivery robots. We all know Neuro is working with, for example, Domino Pizzas to deliver the pizza in the US. Several cities already doing see the action there. But they are not just doing this food delivery. Their technology can be integrated into the full-scale vehicles. And so we will see how they go next step. And probably most people didn't notice that Alibaba has quietly developed their robot testing as well. Recently, it is reported over 1 million shipping orders were complete as of September. Those testing were mostly conducted in the campus in China. It's quite impressive result, and we're eager to see what's the next Alibaba going to do for those kind of technologies. In Taiwan, there have been several pilot programs as well from ARTC and also from E3, not listing here. Last year, Taipei City also working with Turin to pilot and test the AV bus on the streets in Taipei cities. Going back to the fundamentals, when we talk about autonomous driving, and which has profound impact to the futures, not just the industry future, the human being futures. Then we look at how the autonomous driving can be produced and what direction of the autonomous driving vehicles should be. I personally strongly believe all the autonomous driving vehicles have to be zero-emission vehicles. Here, I just use statements from GM to give you some example. But fundamentally, if you believe the future belongs to those autonomous driving machines or equipments, and with their efficiency and reliabilities, one day you would see a lot of autonomous driving vehicles running on the streets, working on long hours. If those vehicles still use the old internal combustion engines, you can imagine what kind of emission and pollution will continue dump into the climate. In order to have a greener future, the AV, especially those highly frequent used AV, have to be zero-emission vehicles. Besides the regulatory push and also recent customer trend change, actually EV provide a better architectures for the vehicle to integrate all kind of autonomous driving functionality and also technologies. Because EV structure is much simpler than the old internal combustion engine architecture. Specifically, for example, the EV provide a faster accelerations and a more precise steering. All those are critical when you have the autonomous driving vehicles on the streets, how to react to the situations which not foresee 10 seconds ago. We need a very dynamic and rapid responsive equipment. So EV actually can provide those capabilities to enable a better autonomous driving utilizations. And also we talk about the new electronic architectures. It's not just for the EV. It can integrate a lot of new functions of the autonomous driving into those developments in a more systematic way and a simpler way. Despite all the progress we mentioned in the previous page and a lot of pilot program or even some of the pioneers already moving into the like AV commercial service, there remains a lot of challenges. We need to look at how to address those challenges to make sure the future can be realized in a robust way. For example, on the technology side, we certainly need better sensors, better integration capabilities. We certainly need better perceptive, predictive artificial intelligence, and definitely the decision making, how we can have a much better or much more robust decision making structure and system inside a vehicle to address urgencies is probably one of the most important things for the autonomous driving. One question still remains is how the autonomous driving vehicles operate in the extreme weather conditions. For example, heavy rain or heavy snows. Those are the things that can block your sensing capabilities, even cut off your network connections. So how we can address those concerns in the new vehicles going to be a test for the capability of the autonomous driving. And of course, cybersecurity is a major issue and has been a major concern for many people, not just talking about hijackings, because information leakages also another concern. Anything connected into the network becomes a point to be attacked. So we must address the cybersecurity issue of the autonomous driving, not just for safety concern, but also security concern. On the business model side, cost structure is probably one of the biggest barriers. EV itself still has some task to do to overcome its high cost. When you add on more autonomous driving functionalities, you can expect the cost going up significantly and very fast. So how to bring those costs down to an affordable level going to determine the future of autonomous driving in a big way. But having said that, even you have a affordable cost structure in autonomous driving vehicles, how to develop sustainable business model also critical. Right now, we haven't seen a really feasible or viable model for example, the shared mobility, and we haven't seen sustainable business model for the mobility as service as well. Those things need to be addressed. On the regulation side, although the US, Europe, and China already roll out some standard and regulations, first of all, they are not complete and they are being updated constantly. But there are also some confusions. For example, in the US, some of the states also roll out their own requirements, and some of the regulation and standards are not clear to the automakers. Even big question mark is on the international standards. How we can have a unified standard or consistent standard across the market that will help the automakers to develop the autonomous driving technology in most efficient way. On the other hand, we can tell road condition becoming a blocks for the roadblocks for the autonomous driving. Even a less clear driving lane will hurt the autonomous driving vehicles. And of course, not all the countries have an up-to-date infrastructure, especially network, can help or complement the autonomous driving vehicles. So those are the big tasks, need government and also industry to work together. Following the regulation and infrastructure, actually there are other blocks, for example, liabilities, how to design liability, especially the L4 plus is one subject. We need to have clear definitions. The other one is ethical decision makings, and we all know that related to the moralities issues, and we need a consensus across the industry and the global to have a standard for the ethical decision makings. Finally, we need to address the customer concerns and continue to provide educations. There's so many new technologies. Although customers do not need to understand every one of them, but they probably cannot just jumping onto a bus and go, because the situation for the future autonomous driving bus will be quite different from today's. So how to build up the confidence levels within the customer base, and how let them know the AV can help them, can help the city, can help the global transportations are going to be very important. In 2017, McKinsey published this chart. At the time, they're talking about different scenarios about adoptions. There could be high disruptions, which means bigger, faster penetration of the autonomous driving, or low disruption scenarios. With all the development in the last few years, especially during and after COVID-19 catastrophes, we can see the people's attitude and also industry's attitude changing. And we also can see the potential benefits that autonomous driving can present to the societies. So personally, I strongly believe the chart, the line will move toward the upper lines, which means I'm quite optimistic about the futures of the autonomous driving. So in summaries, we can say to a fully mature and viable autonomous driving world, still a long-term goal. Safety remains number one priority and also number one challenge. We need even better sensing, computing, mapping, perceptive decision-making, algorithm, all kinds of new technologies. The cost must come down for the vehicle itself and also development cost. We need good infrastructure and system. We need consistent standard and regulation, and ultimately we need right business model. So to make the autonomous driving world a realistic future. From what we've seen so far, commercial application and operation in a controlled environment might have a better chance to succeed early. Finally, this competition about the autonomous driving technologies and also business model is wide open, because so many things could happen between now and the future maturities. And who knows, there could be better sensing technology than the current camera, radars, or LiDARs. And we are eager to see what will happen in the next 10 years. And I encourage all the industry players, if you believe the future belongs to the AV, we need to jump in, because that's not only to move the industry forward, but also to help the world. Thank you.